somebody tell me, we're going to be talking about dimensions. What's a dimension?
Like 3D.
Ah, good. So like 2D, 3D, so forth and so on. Okay, that's kind of like what we're going to talk about today, but we're going to take it from a different direction. If I have no dimension, isn't that a dot? There's nothing to measure, right? A dimension is something that you measure. Okay, if I have a one dimension, that's just a line. I have one thing that I can measure. Two-dimensional means that I have a length and I have a width. Do you remember learning this? Now, I can make this a flat figure. Now I have a two-dimensional. Yes, there are four sides, but this is just two-dimensional because I have a width and I have a length. Three-dimensional, that's when it sticks out, correct? So this little frame here, right, that's three-dimensional. It's a solid figure. And now I would have a third dimension that would stick out from there. Everybody agree with me? You understand what I'm talking about? Okay. Are we good? So that's a third dimension. And then amusement parks pretend like there's really a fourth dimension. What do? They give you those rides that blow air or spit water, drip water, the seats vibrate, right? And they have a claim that that's your fourth dimensional because it's using a different sense. Not only does it pop out at you, but now it's got you're putting your senses there. Okay? There's really technically, mathematically not a fourth dimension yet. Are we okay? They're trying to figure out, well, what would make it a fourth dimension? Okay? So they're talking about it. Now, what we're going to talk about today is a dimension change, but I'm not talking about changing from 2D to 3D. We are strictly going to talk about two-dimensional shapes. So here's a square. If on this square, each one of my sides is 1, what would my shape be if I doubled the dimensions?
Still be 1.
If I doubled my dimensions? Okay, so that means I'm taking each of those sides and I'm making it bigger by doubling it. What is that called when I make a shape bigger? Dilation. So all we're really talking about is dilations. But in the past, we just talked about the sides, or what happened to the size of the shape. What I want us to talk about today is, because we're in this unit of area, what happens to the area of this shape? Okay? Well, what other kind of changes occur if I double those dimensions? Okay, so on your paper, I want you to create a chart or a little table that looks like this. Just ignore this row. I'm going to give you just a second, and I want you to draw this on your paper. Okay, so let's just fill this in. Let me make this a little bit easier on us here. Okay. So these go downwards. So if I'm looking at this shape, what would be my perimeter of this shape right here? 4 what? Centimeters. What would be the area of that shape? What would be the area? What do I do to find area of a square? Length times width. So this would be 1 times 1, which would be what? 1 what? Centimeter squared. Very good. Okay. So then let's inch it over this way. My next shape, what would be the perimeter of this one? 8 centimeters, right? And what would be my area? 4 what? Centimeters squared. Excellent. Okay, then on the next one, what would be my perimeter? 12 centimeters. Very good. And my area would be 9 centimeters squared. Excellent. And then my perimeter would be 16 centimeters. And my area would be 16 centimeters squared. Excellent. Okay, again, I'm not worried about filling this in. I hope you already know how to fill this chart in. What I want us to do is I want us to start comparing what we have here to see if we can figure out some fun new things. So I'm going to cover this back up. And I want us to look at just these two right here. Somebody tell me, looking at just the picture, don't look at the bottom yet. Looking at just the picture from here to here, what happened? We doubled it? What do you mean? We doubled what? The sides. We doubled the dimensions. Okay, we took this side from 1 to 2. That means we made it bigger. We doubled the dimensions. Everybody understand that? What number represents doubled? Times 2, right? Well, what's 1 times 2? 2. So now look down here at perimeter. How do I get from 4 to 8? Can I multiply that by 2? So 4 times 2 is 8. So my perimeter doubled as well. But what about my area? Is 1 times 2 4? But wait a minute, we just doubled our dimensions. Why isn't my area doubled also? The answer for area is always what? Squared. Same thing here. When I double, I'm not just doubling my dimensions for area, I'm doubling it, but it is going to be squared. What's 2 squared? 4 times 1 gives me 4, doesn't it? Does that make sense to you? Okay, let's see how much sense it makes. Let's bring in this next picture. So we're going to always start back here. So how do I get from here to this one? Times 3, what is that called? Cubed or tripling, right? So from 4 to 12, is that times 3? 4 times 3 is 12? Well, what's 1 times 3? It's area, so it's 3 squared. What's 3 squared? 9. So 9 times 1 is 9, right? So when you're talking about the area, whatever you do to your dimensions, you have to square them to figure out what happens to your new area. Are we okay with that? All right, let's bring in this last one over here. So what do I do to get from here to this last one? What is that called? Quadruple, very good. What are we going to multiply by? Times 4. So 4 times 4 is 16. But down here, 1 times 4 is not 16. It's 4 squared. So 1 times 4 squared is absolutely 16. Are we okay? So if we're talking about perimeter, then it's just whatever the dimension changes. But if we're talking about area, we have to square it. So my next question to you would be this. Can you do this with circles too? What would be the dimension for circles? Because circles don't have sides, do they? They have radii. The radius is the dimension. So I want you to create this table on your paper. I'm going to give you a second. Just create it. Don't try and fill it in yet, because I want you to fill it in a certain way. All right. So right here, let's take a look at this first one, right? How do I find the circumference of a circle? What's the formula for circumference? What is it? Yeah, 2 pi r. And what's the formula for area of a circle? Pi r squared. So on this first one, my radius is 1, right? So this would be 1 times 2, which would be 2 pi. So again, don't multiply by that pi, just leave it there. Okay? Just don't multiply by that pi. And then down here, it's pi r squared, so that's pi 1 squared. What's 1 squared? 1, so this would be 1 pi. So on the second circle, now my radius is 2, right? So this is 2 times 2 pi, which would be 4 pi. And then with my radius is 2, it's 2 squared. What's 2 squared? 4 pi. Move on to my third circle. So it'd be 3 times 2, which would be what? 6 pi. And then 3 squared is 9 pi. And then 4 times 2 would give me 8 pi. And then 4 squared is 16 pi. Again, if I gave you enough time, I believe that you could totally fill out this by yourself, correct? But I'm not worried about us filling this out. I'm worried about us comparing what do we know. So what did we do to get from the first circle to the second circle? What did we do to the dimensions? Good, we doubled them, right? So we multiplied times 2. So 2 pi times 2 gives me 4 pi. But 1 times 2 doesn't give me 4. Because it's area, remember, we have to square that. So it's 1 times 4 gives me the 4 pi. What do I do to get from here to the third circle? We tripled it, right? So it's going to be times 3. So 2 times 3 gives me 6 pi. Here, 1 times 3 doesn't give me 9, though, because it has to be 3 squared. And then the final one, to get from here to here, what is that called? Quadruple, very good. Which means we're going to multiply by 4. So 2 times 4 gives me 8. But 1 times 4, remember it's 4 squared to give me the 16. Are we okay? You're like, yeah, Ms. Ramsey, this is all good, but I'm not quite understanding. It's okay. Okay, so let's take a look at some of the questions. I'm going to give you just a minute, and I want you to read through this question so that we can have a discussion about it. Okay, tell me, what is one of the main keywords in the question being asked? Doubled. What does doubled mean? Times 2. What is the other keyword that throws that word off? Area. So when we're talking about area, what do we have to remember to do? We have to remember right here to square it. So is my shape going to be reduced? Is my shape going to be constant? What does that mean, constant? Stays the same. Is it going to be doubled? It's not going to be doubled. Yes, it's doubled, but because we are talking about area, area is squared, which is why it's going to be 4 times bigger. So J is the correct answer here. Do you see why they're going to trick you? Because you're going to see the word doubled and double in the answer, and that's what you're going to choose. It depends on what we're talking about as to how it really changes. Okay, I know that you can't read this in the way back of the class. It's basically saying that I have an amusement park and that the diameter is 50. Okay, it says that the owner is going to double the radius, and it wants you to describe what's going to happen to the circumference and what's going to happen to the area. I'm going to read through the choices. I don't want you to answer it, I just want you to listen and see if you can figure out which answer do you think is correct. A says that the circumference and the area will double. B says the circumference and the area will quadruple. C says that the circumference will double and the area will quadruple. And D says the circumference will quadruple and the area will double. Let me show you what we just talked about. What we just said is, if I double my dimensions, what happens to my circumference? What happens to it? What did we do? We doubled it, right? What happens to my area? It's going to be quadruple because it's 2 squared. That's all this question is asking, is what we just did on that chart. So my circumference will double, but my area will quadruple. My circumference will not quadruple, right? So my circumference will double and my area will quadruple. C is the correct answer. How many of you chose C? How many of you were clueless that you had no idea what we were talking about? How many still don't know because you're not paying attention? Oh, because you're not paying attention. Very good. All right. Write this in your notes. One of the things I'm going to be looking for when I take your journal grade. Make sure you copy this down. See, what does this mean? Well, this means that perimeter is to the first power. So if they tell you we are going to double our dimensions, it's 2 to the first power, which really just equates to 2. Down here, area is squared. It is to the second power. So if I'm going to double my dimensions, we have to square it, which really means that it's going to be times 4. So whatever you do, whenever they're talking about perimeter, just know that it's to the first power. So however they change your dimensions, that's how you change your perimeter. Whenever you're talking about area, however they change your dimensions, you have to square it. If they tell me it's getting 16 times bigger, I have to square that number. Are you with me? That tells me what a new area is going to be. All right, here's this next problem. I want to give you a second to read through it and see if you can come up with the answer. And then I'm going to tell you what's going to happen to problems so that way you won't be able to work it the way you're used to. Tell me, what's the most important word in this question? Doubled. What else? Area. So when you see the word doubled and we're talking about area, how did you work this problem? What did you do?
Like the 2 sides by 2 and then did the area formulas in there.
Good. So you doubled your sides. Well, they gave you your sides, so you just said 3 times 2 and 5 times 2. So that means it's going to be 6 times 10, which is 60. Okay, how many by a show of hands did it that way? Okay. That's fine, because they gave you the dimensions. The problem with that is this. What we're moving to, what they're going to do, is they're not going to give you this information. What they're going to say is that my area is 15 inches squared, and they're going to double the dimensions. What's going to be your new area? So I'd have to multiply this by 2 because we're doubling it, but because it's area, I'm going to have to square it. So what is 15 times 4? It's still 60. Okay, it's just a matter of working a problem different based on the information they gave you. Does that make sense? Some of you in the past have seen problems like this, and it took you like forever and a long time to go back and try and figure out what those dimensions could have been. Well, I'm not worried about what the dimensions are. I just want to know what's the new area going to be. Okay, so if you think about these little magic numbers that I just taught you, you should do fine. Okay? So here's what I want you to do. You have your homework that you can be working on. You also have your homework from Friday if for some reason you didn't do your homework, right? Make sure you have them both ready for tomorrow.